Any data you collect can lead to a misleading conclusion. Sometimes it's just our job to ask the right questions and to set the surveys up the right way. So here's this person, Karen, surveying middle school students about their favorite band. So that's the question. And they asked a lot of people, 1,156 students. Oh, excuse me. Out of the 1,156 students, 65 sixth grade students were surveyed, and more than half of them said their favorite band is Rhonda and the Gees. So, first of all, we see a problem that they're only surveying sixth graders, but let's keep going. Let's see, there's more to it. Based on the survey, Karen says that most middle school students' favorite band is Rhonda and the Gees. Why is this incorrect? Well, I mean, if you want to know what the whole school likes, and well, we don't really know what grades are in the school, so that's a little bit misleading. Um, and we also know that they only surveyed 65 students. So let's look at the choices here. It says they surveyed too many students. I mean, that's absolutely not the issue. 65 is a very small number. It was too small, I believe. Did not survey any high school students. Well, that wouldn't make sense because we don't want to know what the high school students think. We want to know what the middle school students think. Karen did not include enough bands in the survey. Well, this is interesting. Okay. We don't actually know what she asked or what she included in the survey. And so our only choice is that G, she surveyed too few students. But I should point out that there's some error in here. Unless this middle school only has sixth grade students, then there's a problem with asking just sixth grade students. And the misleading data here, like if we were to work in reverse and she was to actually just come and present her findings, which are that the favorite band in the school is Rhonda and the Gees. Now, if you're sitting there listening to this, you have to wonder, well, who did she survey and why? Because otherwise, if you just believe this, you're walking into some misleading data. Another example is, let's say, salaries for a company. Companies advertise sometimes average salary, and then you make a decision to apply for them based on that average salary. So let's say there's one company, and here's what some salaries are: 10,000, and then 12,000, and then 15,000, and then 100,000. Okay, so this is a company. You don't know how big the company is walking into it. You just know that they have the following average, a mean. Let's figure it out. What's the mean average of the salaries? Well, 10,000 plus 12,000 is 22,000, plus 15,000 is 37,000. It's $137,000 divided by the 4 people that work there. 4 goes into this. 20, 31. Well, I'm going to break it down how I'm doing it. 100 divided by 4 is 25. And then there's 37 left over. 37 divided by 4 is 9. Add the two together, this is 34. So 4 goes into this 34 times. And there's 1/4 left over, which is 0.25. Okay, what does that mean? So $34,250. They could advertise that the average salary of this company is $34,250. Then you go there and apply. What salary do you think you're going to get? I mean, if the majority of the company is falling within this range, and there's one person here, this is not an accurate measure of what the most likely salary is. I mean, it depends what they're hiring you for and along the chain. But let's say the majority of the companies down here, it's more accurate. This is to say the median salary is halfway between these two. 27,000 divided by 2 is 13,500. That the median salary is 13,500. That's a little bit more accurate of a statement. So be careful when you have data with some kind of outlier or something that would throw the rest off. Otherwise, you can lead to some misleading data and information.